These are end of chapter questions. If you want to find them, they're in your textbook, okay? So I've just taken them right out of your textbook, verbatim. Number one, Table 1.4 contains the production possibilities data for capital goods and consumer goods for the economy of New Harmony. So what we have here is a table. What we have, just let me bring that up. Capital goods, consumer goods, and various combinations represented by A through E. Okay, here are various combinations of potential amount of capital good and amount of consumer good that the economy make. Because the economy has limited capacity, we have to make choice. Okay, so what we're getting at here are the various choices of product levels that we can produce. So if we choose to make all consumer goods and no capital goods, the combination of output is no capital goods, meaning 0 capital goods, 30 consumer goods. On the opposite end over here in E, we're choosing the exact opposite combination. We can produce all capital goods. And if we choose all capital goods, we can make 20. And if we make 20, we can't make any consumer goods. So these are the two extremes. B, C, and D represent combinations of the two extremes, okay? So if we say, okay, let's make 8 capital goods, well, that means some of the consumer goods have to be reduced because that's the trade-off. So we can only produce 27 consumer goods. If we produce 14 capital goods, we can only make 21 consumer goods. And if we make 18 capital goods, we make 12 consumer goods. A couple things I want you to notice here. You'll notice that we have some increases in capital goods. So we got from 0 to 8, so that's an 8 increase. From 8 to 14, which is a 6 increase. 14 to 18, which is a 2 increase, an increase of 2, I should say. Or sorry, an increase of 4. I can't add or subtract. And 18 to 20 is 2. Okay, so you see 8, 6, 4, 2. Consumer goods, on the other hand, we're seeing those start off at 30 and diminish as we go on. 27 to 30 is a decrease in 3. 27 to 21 is a decrease in 6. 21 to 12 is a decrease in 9. And 12 to 0 is a decrease in 12. Okay, so what we're showing here is the various decreases. So the first thing that you want to do in here is use a grid, figure 1.6, to draw the production possibilities curve for New Harmony and label it PP1. Label each of the 5 output combinations with letters A through E. So in the event of, just to give you an idea of how to do this, just in case you're not clear, so capital goods, consumer goods, A, okay, 0 and 30. So what we do is we got capital goods here, 0, and 30 would be the first. 8 and 27 will be the second. So 8, 27, the spot here. So what we're going to get is this right here. We're going to get A, B, C, D, E. So this is what it's going to look like. So 0 and 30, 8 and 27. Okay. 14 and 21, and so on. So what you should end up with is a curve that looks like the red line here. Assume the people of New Harmony have decided to produce 12 units of consumer goods. How many units of capital goods could they produce? I'm going to do this 2 ways. I'm going to look at the numbers first, okay? Assume the people of New Harmony have decided to produce 12 units of consumer goods. So if we go over here and we look at consumer goods and we find 12 units of consumer goods, they can make 18 capital goods. 12 equates to 18 capital goods. Or if we go to the graph, 12 units of consumer goods right here would equate to 18 units of capital goods. So you can read it off the graph, or you can read it straight off the table. C says, assume that the people of New Harmony have decided to produce 11 units of capital goods. Approximately how many units of consumer goods could be produced? So, okay, 11 units of capital goods. Again, we'll go to the table first. And we don't have an 11 here. We got 0 to 8, 8 to 14. So it's between 8 and 14. So 11 is, I'm going to say it's approximately, it is halfway between 8 and 14. So what we do is we go halfway between 27 and 21. So 27 and 21 would be around 24. Now, you can also pull that right off the graph. So you can think, okay, so the question asks us 11 units of capital goods. So we go look at capital goods right here, 8. This is 12, so 11. And we draw a line up from about 11. There it is at 24. What is the total cost of the first 14 capital goods? Now, this is like problem on your assignment. What is the total cost of the first 14 capital goods produced? Now, what does that mean? Well, what that's really asking is, what do we have to give up of consumer goods in order to make the first 14 capital goods? So let's go back to our table here. If we go back to our table, we're producing nothing, we're producing 8, we're producing 14. So here's the first 14 at point C, okay? See how we've gone from 0 to 14 here? In order to go from 0 to 14, what happened to the equivalent production of consumer goods? Well, we started off at 0, we made 30. As we work our way to 14, we're only making 21. So if we didn't make any capital goods, we can make 30 consumer goods. If we make 14 consumer goods, 14 capital goods, we can only make 21 consumer goods. In other words, in order to make 14 capital goods, we have to give up 9 consumer goods. The number of consumer goods dropped by 9 in order to cause the capital goods to go to 14. See how we concluded that? We can also read that right off the chart. We can say, okay, if we're saying what is the cost of the first 14 capital goods? Okay, let's take a look at capital goods. Let's go over to 14 here, which is about right here. Okay, so it's right there. What we saw was we're going to say, how many consumer goods did we start off with? Well, we started off with this number. Now, if we draw a line across here, we're down to this number. In fact, we can say that it dropped from 30 down to about 21. So what's the total cost of the first 14 capital goods? 9 units. We dropped 9 consumer goods. The number of consumer goods went down by 9 in order to get to 14. So this means going from combination A, which entails 0 capital goods, to combination C entails 14 capital goods. This would mean the production of consumer goods would drop from 30 to 21, a difference of 9 units. See how we did that? Looking at E, assuming the economy is producing at combination C, what is the total cost of 6 additional consumer goods? Okay, we got to look at combination C, and then we're going to add 6 consumer goods to it. So let's go back to the table first. Okay, so what we're saying here in this particular problem is assume we're working at combination C. So combination C is 14 capital goods and 21 consumer goods. What is the total cost of an additional 6 consumer goods? So let's go down to consumer goods. We went from 21, add 6 to that. So 21 and 6 more is total of 27. So we're moving to point B effectively, okay? We started off at 21. That says, what's the cost of 6 more? So 6 more is 27. What is the cost? Well, we could produce 14 capital goods when we make 21 consumer goods. If we went to 27 consumer goods, we could only produce 8 capital goods. So 14 minus 8 would be 6. We would have to reduce our capital production by 6 in order to bring up our consumer production by 6. Let's look at F. Assuming the economy is producing combination B, and we look at the combination B is 8 capital, 27 consumer, okay? What is the approximate per unit cost of an additional capital good? Now, assuming the economy is producing combination B, what is the approximate per unit cost of additional capital good? Okay, let's go here. Okay, so what we got is assuming the economy is producing a combination B. Okay, here's combination B. So that's capital goods, consumer goods, okay? What is the approximate per unit cost of an additional capital good? Well, we can't tell directly because there's no number 9. We don't have we got one more capital good would be 9, and 10, 11, 12, right up to 14. So what we got to do is guess. It's somewhere between 18 and 14. So what is somewhere between 8 and 14? So we know the difference is 6 here. 8 and 14 to 6. So we know that at combination B, you can make 27 consumer goods. And at combination C, you're only making 21. So what happens here? It goes down by 6. So an increase in capital by 6 equates to a decrease in consumer by 6. So basically, it's a one-to-one relationship. So if we add one more capital good, 9, we would have to decrease one consumer good to 26. See? Because it's a 6, change of 6 at this one, change of 6 at this one. So one more would be an additional 1 and 1 less. Next question. It says, assuming the economy is producing at combination C, what is the approximate per unit cost of an additional capital good? So we got to go look at combination C now. Okay, so here we're looking at combination C. And the question says, what is the approximate per unit cost of an additional capital good? Well, okay, so we want to potentially add a capital good. So we know from 14, we don't have 15, 16, 17, but we do have 18. So from 14 to 18, that's 4 additional units. 4 additional units of that one causes a change from 21 to 12. In other words, 21 minus 12 is 9. Okay? So we got a 4 increase results in a 9 decrease. That's about 2 to 1. I'm going to say every 1 increase in this one causes 2 decrease in that one. So it's a little more than 2. 2 and a little bit of change. 2 1/4, whatever. So as we go from 14 to 15, it would cause this one to drop by about 2 and a little bit. You see where I got that?
Yeah.
So it's really a 4 over 9, 4 ninths.
Right.
That's the combination there.
Mm-hmm.
Okay, so the last question says, what law is illustrated from your answer F to G? Well, F and G, what we saw, let me find that question. What we saw between F and G, we saw that in this one, it was a 1-to-1 combination, 8 to 14, 27 to 12. That was about a 1-to-1. In this one here, it was about a 2-to-1. A change in 1 here causes a change in 2 here. So what we're seeing as we move this way, as we get more and more capital goods, we're seeing an increased cost. In other words, you got to give up more consumer goods in order to squeeze more capital goods out. So this is what we call the law of increasing costs. As we produce progressively more of one, we got to give up progressively more of the other. So this is what is known as the law of increasing costs. Cost per unit of capital goods increases as we try to produce more capital goods. Okay? Fill in table 1.5, assuming that 10 years later, the output potential of capital goods has increased by 50%, while the output potential for consumer goods has risen by 6 units for each combination A through D. Now, that can be a little stumbling, okay? Fill in table 1.5, assuming that 10 years later, okay? Let's assume this is 10 years later. So this is the same numbers. We're using the same numbers right here from table 1.4, okay? But here's what's changed. The output potential for capital goods has increased by 50%. So I'll take one at a time. The output potential for capital goods has increased by 50%. So what we need to do is go back and look at our original capital goods. And the output potential is increased by 50%. 0 plus a 50% increase is still 0. 8 plus a 50% increase is 8 plus 4, which is 12. 14 plus a 50% increase is 14 plus 7, 21. 18 plus a 50% increase is 18 plus 9, 27. 20 plus a 50% increase is 20 plus 10, which is 30. So our new numbers will be 0, 12, 21, 27, and 30. The second one says the output potential for consumer goods has risen by 6 units in each combination A through D. So that was pretty straightforward. All we need to do is take this number and add 6 to it. 30 plus 6 is 36. 27 plus 6 is 33. 21 plus 6 is 27. 12 plus 6 is 18. And 0 plus 6 is 6. So what we can do then is to effectively fill in that table and draw the new production possibilities curve. So what you're going to find is you'll have the new table will be filled in, and it will say 0, 12, 21, 27, 30, 36, 33, 27, 18, and 0, like that. That's what it should be looking like. And then we can draw the production possibilities curve. I'm going to draw it on the original curve. So I've drawn it here on the original curve, 36, and right down there to 0. So we see that the curve has moved out and a little bit further here because we got percentages and raw numbers. So the curve has basically been moved out. Okay? Which is typical when we have an increase in productivity. Number K says, as a result of the economic growth, can New Harmony now produce 24 goods, capital goods, and 26 consumer goods? Okay, so 24 capital and 26 consumer. So if we go look at our chart here, the table we've just drawn, we ask ourselves, okay, can they make that combination of 24 capital? So let's go over to capital here. Okay, well, we don't have 24 written in here, but it's somewhere between 21 and 27. And we don't have 26 written in here, but it's somewhere between 27 and 18. So this requires some thought here. 27 to 21 is a difference of 6. 27 to 18 is a difference of 9. Okay, 6 and 9. So 24 is 1, 2, 3, which is halfway. And 27, so this would be halfway. So if it's a difference of 9, that's 4.5. So that's really 22.5. So the combination we're being asked for is 24 and 26. So if we know now, we can only go about 24, and the combination they're looking for, the magic combination, is 26 consumer goods. So the answer is no, we cannot get to 26. And if we look at the chart, I don't mean to jump around too fast on you here. I'm going back to the chart. If we look at the revised chart, and if we've got it drawn on a nice sheet of graph paper and it's relatively well presented, if we asked ourselves, can we make that combination? Well, the combination is 24 capital, okay, and 26 consumer, and the point will be right here. Notice that, oops, I can't tap on that. Okay, so here's the point right here. And you'll notice that the point is outside, beyond, somewhere up here, beyond the production possibilities curve. So as long as it's beyond the production possibilities curve, it is not possible. So that combination, that magic combination that they want of 24 and 26 is not achievable. Why? What are the possible reasons that would explain the shift from production possibilities 1 to production possibilities 2? Okay, so if we had to ask ourselves, why is it that we've got this increase in productivity? What happened to do this? Well, you have to think about, well, what changed in the factors of production? Land? Maybe we have better resources, more resources. Maybe we found a new mine, or we found a new reserve of product or something that's a lot less expensive. Okay, so that's one. Labor could be better trained. We could have better quality labor doing things more productively. They can make more with less effort. Or we can think of our capital stock. Maybe we got equipment. If you're drilling a hole, and here's what I mean by productivity. If you rely on people to drill a hole with a hand drill, a turning hand drill versus an electric drill can drill through a hole about 50 times faster than the hand drill. So maybe they got electric drills now. So technology, for example, that is caught up in capital would certainly improve. So that would account for the production possibilities curve moving to the right. I want to look at this next problem. These are what are called the basic problems. And these are of the nature that you will find on the assignment. So answer the questions below based on figure 1.7 in the country of quartz. I just love some of the countries to come up with in this economics book. So what we got here is a coffee and tea, various combinations of coffee and tea. And we've got, we can see that that there is a relationship there. And the question is really being asked is how much tea is gained and what is the cost of coffee? So how much tea is gained and what is the cost of coffee? So if we look at this one, in moving from U to V, okay, so U to V is really right here to right here. In moving from U to V, blank T is gained at a cost of blank coffee. So let's see. So W to X now is the same sort of thing with W to X. So here we are, W to X. First, we'll look at T. Okay, so we went from W is 35 T to 55 T. So 35, 55 is 20. So we had an increase in 20 T. But what is the cost? Well, look, we went from 100 coffee being produced at W
to 70
down to 70. So 70 minus 100 minus 70 is 30. So 20 T at a cost of 30. So we see that the cost of moving to more T is increasingly eating away at the amount of coffee that we can produce and at a greater rate. In moving from Y to Z, so if we look at Y to Z, well, what did we get? We went from about 65 to 70. So that's a 5 increase in T. But what is the cost? Well, our coffee production dropped from 30 down to 0. So we had a 5 increase in T at a cost of 30. Let's take a look at the next one. Table 1.6 shows the production possibilities curve for the country of Emilion. We got table 1.6 there. We got rice and we got beef. And we know that if we produce no rice, all the way up to 140 rice. So, and we produced from 50 beef down to 0. So what this is really saying is our economy got two extremes. we produce all beef and no rice in A. And in E, we produce all rice and no beef. Okay? And the various combinations in between. So complete the following approximate possibilities for a million. So we've got the approximate here. So what is the approximate possibility? 130 rice. Well, let's take a look at rice. We do not have 130 in here, but 130 is halfway between 120 and 140. So if that's halfway, we assume then that it's halfway between 20 and 0. So our beef, if we made 130 rice, we should be able to make 10 beef. So that's where we get 10 there. So 20 minus halfway between 20 and 0. 10. Okay? B says blank rice and 40 beef. Well, let's take a look at beef. We do not have 40 beef in the list, but 40 beef falls between 45 and 35, which is combination BC. So that means that the rice must be between halfway between 50 and 40, 50 and 90. So the difference is 40. So that would be 20. So about 70. So that would be about 70 rice equals 40 beef.
Mm-hmm.
Which of the following possibility is Emelian capable of producing? Okay, so what we got is capability here. Can we produce 100 rice and 40 beef? Well, let's go to 100 rice, first of all. 100 rice are somewhere between here and here. Okay?
No.
And we ask ourselves, well, the beef production has to be somewhere in between here too. But 40 is well beyond that. So, possibility is somewhere between 35 and 20. 40 is not possible. No. Let's look at 70 rice and 35 beef. So if we go to 70, which is halfway between 50 and 90, we should be able to be about halfway between. So yeah, we're going to be higher than 35. So yes, we certainly can produce that combination. Okay? Let's look at number 3. Number 3, table 1.7 shows the production possibilities curve for the country of a million again. And we've got rice and beef again. Okay, same table. So we ask ourselves, what is the total cost of producing 90 rice? Let's just go up here then and look at it. We've gone from 0 to 90. In order to get from 0 to 90, we had to reduce our beef production from 50 down to 35. So 0 to 90, 50 minus 35 is 15. Yes. So the total then would be 15 beef. That would be the cost of producing 90 rice. What is the total cost of going from possibility C to possibility D? So here's C, here's D, 90 to 120, 35 to 20. So in order to go from 90 to 120, we had to give up so much beef. So we increased by 30. We decreased by 15. In order to go from that to that, we got an increase in rice of 30 and a decrease in beef. So effectively, for every rice we add, okay, we had to give up half a beef. Okay, so it's I'm going to say it's a 2 to 1 rice beef per unit cost, twice as much. D, what is the total cost of going from D to C? So we went from D to C. So if we went from 120 rice to 90 rice, that means we gave up 30. And we got an additional 15. So effectively, if we give up 30 rice, we can get 15. So it's a 2 to 1. It's the opposite combination. See that? Number 4, Utopia produces only 2 products, cheese and wine. The production levels are shown in table 1.8. So here we've got we see percentage of input, but our key thing is our output. Okay, what we want is to say, okay, look, here's our output. Went from 0 to 80, and our wine output from 0 to 110. This is the same table as we've looked at before. It's just a revised format for that. Okay, so this is a revised format for exactly the same table. So what we have to do is to put it in on this table here. So if we produce 0 cheese, okay, we'd ask yourself how much wine could produce if we didn't produce any cheese. So we just look across here.
110.
110. If we produced 30 cheese, we could produce 105 wine. If we produced 50 cheese, we could produce 95 wine. If we produced 65, we could produce 70 wine. If we produce 75 cheese, we could produce 40 wine. And if we produced 80, we could produce no wine. So what we've effectively done, then is redrawn this table. So it's 0, 30, 50, 65, 75, 80. And this one then would be 110, 105, 95, 70, 40, and 0. So those are our combinations that would be in that table, just taken right from this. Okay? The question then asks is, can Utopia produce 65 cheese and 95 wine? So we go down to our table here, which I tried to fill in manually. It's too hard, so I didn't. So can we produce 65 cheese? So let's see now. If we produce 65 cheese, which is combination D, 65 cheese, we can only produce 70 wine. So can we produce 65 and 95 wine? The answer is no. Okay? If Utopia is producing at D, now D is 65 cheese, 70 wine. What is the total cost of 10 more cheese? So we went from 65 to 75. Okay, this one here is 65, this one here is 75. And in order to get from 65 to 75, our wine production went from 70 to 40. Okay, so we had a 10 increase between D and E, so that would be 10. And we had a 30 decrease in the amount of wine from 70 down to 40. So what is the total cost of 10 more cheese? In this case, it would be 30 wine. If Utopia is at D, and again, 65 and 70, what is the total cost of 25 more wine? So we're at D, and we ask ourselves, well, how do we get the 25 more wine? Well, this is 70. This one here is 95. So we went from 70 to 95, which is 25. In order to get there, our cheese production went from 65 to 50. So we had to give up 15. So the cost is 15 cheese in order to get 25 more wine. Okay, question 5. Show Lanark's production possibilities here. Okay, we got wheat and cars and various combinations. So again, just want to make sure the way these things are always set up. If it doesn't produce any wheat whatsoever, 0, it can produce 21 cars. The other extreme is it doesn't produce any cars, it produces wheat instead, 52. So these are the two extremes, right, where it produces either one or the other. Everything in the middle is a combination of the two. So if Lanark produces 16 cars, approximately how much wheat can it produce? So let's go and find 16. Oh, there's no 16 in here. Okay. But we know 16 is between 14 and 18. Okay. So 16 is exactly halfway between 14 and 18. So what we need to do in order to figure out the number of wheat that can be produced is really to say, well, what's halfway between 45 and 35 or 35 and 45? So approximately 40.
Yeah.
So that's how that would be. It would be halfway between. If Lanark is currently producing a combination C, so combination C is 35 wheat and 18 cars, what is the cost of 10 more wheat? So let's go add some wheat onto that. So we've got 35 and it wants to add 10 more, it brings it up to 45. So 35 to 45 results in cars to decrease from 18 to 14. So a 10 increase in wheat would result in a 4 decrease in cars. So the answer in cars is the cost is 4 cars. A Landmark is currently producing a combination D. Combination D is 45 wheat and 14 cars. What is the approximate cost of an additional car? So let's say we want to go from 45 and 14. So we want one more car. One more car is 15. So that's going to result in some reduction in wheat. So 45 to 35 is 10, and 14 to 18 is 4. So if that's so it's a 4 to 10 type of relationship. So one more car, okay, would be about 2.5 wheat. So we'd be down, we drop our wheat by down to about 42.5. Number 6, looking at number 6. Shangri-La produces only 2 goods, bats and balls. Each worker comes with a fixed quantity of material and capital, and the economy's labor force is fixed at 50 workers. In other words, land, labor, capital, and enterprise are fixed, so our production possibility curve is more or less set. Table 1.1 indicates the amount of bats and balls that can be produced daily by the various output quantities of labor. So what we've got is, okay, we've got a varying number of workers from 0 to 50. We've got the production of balls that combination can produce, okay? So if no workers are working on balls, no balls can be produced. If 10 workers are working on balls, 150 balls can be produced. If 50 workers are working on balls, 400 balls can be produced. Okay, so that's the first half. The second half, we take that same group of workers and we say, well, let's just focus on making bats. So if you put no workers to work making bats, you're not going to make any bats. If you put 10 workers to make bats, 20 bats. 50 workers, 55 bats. So this is the same type of chart that in a different format. So what we've got is 50 workers. They either make bats or balls. So very simply, if they make all balls, which would be combination, if they make all bats, if that's the combination of, okay, nobody is making balls at all. Everyone's making bats. So if there's no balls, no workers working at, the combination is 0, and and that means 50 workers that are working on bats. That means we can produce 55. So the A, what I would call A, the combination A is 0 balls, 55 bats. The opposite extreme is where we say, okay, look, none of our workers are making bats. All of our workers are making balls. So if we took 50 workers and we put them together to make balls, they could produce 400. But because everybody's working at making balls, nobody's making any bats. So the other extreme combination is 400 balls and 0 bats. Everything else in between, the combinations in between. So if you had 10 workers making balls, you could make 150. That means you got 40 workers, the difference between 10 and 50 workers in total, 40 workers making bats. So you could make 52 bats. If 20 workers were making balls, you can make 250 balls. That means 30 workers are busy making bats. So the combination would be 46 bats. If you had 30 workers making balls, you could make 325 balls. And that means you got 20 workers left over to make bats, 36. And if you had 40 workers making balls, 375 would be the output. And that way you'd have 10 workers to make bats, 20. So these would give you the combination. So if we think about what the chart would look like, or what the table would look like, it would be balls and bats, and combination A, B, C, D, E, and F. And the first combination will be 0 balls, 55 bats. Second combination will be 150 balls, 52 bats. Third combination, 250 balls, 46 bats. D combination with 325 balls, 36 bats. Fifth combination would be 375 balls, 20 bats. And final combination will be 400 balls and no bats. Okay, so that's to make that combination. So we would have it look like 0, 150, 250, 25, 75, 400. And bats will be 55, 52, 46, 36, 20, 0. Okay. So what is the opportunity cost of increasing the output of bats from 46 to 52 units per day? So 46 units per day, so the bat combination, that would be combination C. Combination C would be making 46 bats. And combination B would be 52 bats. So 46 to 52. And that would create, that would mean that we would have made 250 balls. And we could make only 150 in that combination. So from 46 to 52 would result in 250 minus 150, 100. It would effectively, the cost would be 100 balls. That would be the opportunity cost of creating, going from 46 to 52 units of bats. Suppose the Central Planning Office dictates that output should be 250 balls and 61 bats. Okay, is this combination possible? So again, I should have filled in some numbers here. I just got lazy when I did this. And I'm going to say that, okay, so 250 balls, that's combination C, where we make 250 balls. And the maximum number of bats that we could make if we make 250 balls is 46. So if the planning people, the a command economy, this would be Central Planning Office dictates 61 bats and 250 balls. Is that possible? No, it's not. We can only make 46. That's the possible combination there when you do that.